I would like to start talking about something that most of us, if not all, can relate to: finding a job. Finding a job can be exciting, but most often it's so crushing. Luckily for us, Otta, a startup that was founded 3 years ago, aims to overcome this situation by recommending jobs with a candidate first approach. And my project during the past weeks aimed to help them achieve this goal. A key part of their mission is to recommend the best job offers for you. So they need to provide recommendations that are personalized. And how do we provide those personalized recommendations? Well, a good way to do it is by using collaborative filtering, which is a machine learning technique that filters out items that a user might like based on similarities with other users. How it does it is by considering users that provide ratings on certain products, like job offers in our case. And then it calculates the similarities based only on those users' past behavior. And given that Otta has accumulated more than 50 million candidate job interactions, and it has a variety of the candidate profiles and job ads, that algorithm was a good starting point. How it calculates the similarities by using method called matrix factorization, that what it does is calculating a score that represents the probability of a user liking or not a certain product, so a certain job. And the way to do it is by first starting with a matrix of the past registered interactions, like the one we can see on the slide. And if we wanted to know if James, for example, likes job C or not, what the algorithm would do is go into the database and see if there's any other users that had similar behavior. So, for example, we can see that Fabian rated similarly to James some jobs as Amber did. And in both cases, those users did not like job C. So if we want to make a guess, we would expect that James won't like that job C. And how it does that is by including some latent filters in the algorithm, so it captures the hidden patterns in users' behavior that are not detected by humans. In addition, it includes a bias that can adjust the value of those latent features depending on the user's own rating scale and the popularity of certain jobs. And once we have those predictions, the next step is to calculate or validate those predictions. So how we do that is by using a new but known group of users called the test data set, and we calculate the error between the prediction and the real outcome. However, life is not so simple, and instead of using the absolute error, we need to provide further performance metrics to fully understand how the algorithm is working. For this, Otta had been using the mean squared error from the predictions. And while that was a fast, good approach, I aim to include a few more that would take into account the characteristics of the problem at hand. And that included considering that it was a binary classification task and that it's key to provide relevant jobs to the user as the first job offers that they see. Combining these metrics and the possibility then to optimize the parameters of the model, I saw that the model was not performing as well as we expected when recommending job offers to users. And that was due to sparsity. So even if we had lots of reactions, most of them were not informative enough to detect the hidden patterns in the behavior. And that means that instead of considering the latent features, the algorithm was basing recommendations only on the bias. Given this situation, we had to find a solution. So I suggested to use a new algorithm called the content-boosted collaborative filtering model. And in this case, the algorithm considers the user's behavior as it was doing before, but it also takes into account content features, which are characteristics that describe the user preferences or the job descriptions. And with this combination, it helps us decrease error and provide better recommendations. That means that we can combine the advantages of one method, the collaborative filtering, so the need of not understanding in advance the features and helping users discovering new interests, but also the benefits of the content-based algorithm, so allowing us to overcome sparsity or overcoming the lack of history from a previous user as well as recommending to users with unique taste and recommending new and unpopular jobs to the users in our platform. With these results, what we obtain is that job seekers can now get better recommendations and that small businesses can get targeted and boosted exposure. And this overall can help users stay more engaged and help growth of the company. With this, I'm very happy to have presented my project and thank you all for your attention.